Hey guys! Today we're going to be talking about lesson 43, which is sine, cosine, and tangent, and their inverse functions. So first of all, every time we use SOHCAHTOA or sine, cosine, and tangent, we're talking about a right triangle, okay? And basically with these right triangles, we can set up these ratios that compare side lengths. Just recall in a right triangle you've got the legs here and you've got the hypotenuse. When you're looking at a certain angle, the side that's opposite right across from that angle is called the opposite side, okay? So when we look at sine, for instance, sine stands for opposite over hypotenuse. And so we would be talking about, if you're looking at a certain angle, since it says sine A, we're talking about the side that's opposite angle A, which is 3. And then you would be writing that over the hypotenuse, which is 5. Okay? So we've got the opposite, we've got the hypotenuse, and then this one is called adjacent, just meaning next to. And so this would be the side that is next to the angle that's not the hypotenuse. Okay? So that would be a 4. That would be adjacent. So looking over here, so we've got sine, opposite over hypotenuse, and then we would have, we could write our ratio for cosine. Cosine, up here, this stands for cosine, is adjacent over hypotenuse. So if we look back, again, cosine A, we're looking from this angle. If you're talking about the adjacent side, so the A stands for adjacent, that would be 4. 4 over the hypotenuse is 5. So for this one, we would write 4 over 5. Okay? Then the final one, the final trig function, is tangent. And so that one says tangent is opposite over adjacent. So again, looking from angle A, we're going to say, okay, the opposite side is 3. And then that'll be written over the adjacent side, which is 4. So tangent of A would be 3 over 4. And again, those are just ratios that you use to describe, the right triangles, okay? Make sure you're only working with right triangles. If you wanted to, instead of the ratio, you could write it as a decimal if you wanted to. You could say, in your calculator, 3 divided by 5, you'll get 0.6. So you could say that sine of A is 0.6 or 0.6. For this one, cosine of A equals 0.8. 4 over 5 is 0.8 or 0.8. And then tangent of A, you can write it as 0.75. Okay? So either one of those work. You can use the decimal or you can use the fraction. Sometimes you just see it as a fraction. Make sure, again, you're in degree mode when you work with these, because these are all dealing with degrees. Okay? And so now that we know some of that, we're going to go on to our examples. So example 1, we have these triangles that are given to us, and they ask us to write the sine of A, the cosine of B, and the tangent of C. And they're talking about 3 different triangles here. So on the first one, they're giving us angle A here, and then they give us these sides, 5.74. They ask us on this one to find the sine of A. Okay, so if we're going to find the sine of A on this one, we're going to have to do sine from angle A equals. And then remember, the sine is the opposite over the hypotenuse. So looking at angle A, we're going to go opposite, which is 4, over the hypotenuse, which is 7. Seems easy enough, right? So that's the first one. Then for the second part of that example, they ask you to find the cosine of B. So I'm going to draw this triangle. They draw it like that. They have a 5, a 7, and an 8.6. And here's B. And again, they ask you for the cosine. So, I'm going to write it over here. Cosine, now from angle B. Okay? And this is the angle B. So the cosine, remember, is the adjacent over the hypotenuse. So we're going to just do the side that's next to the angle B, that's not the hypotenuse, is 7. So cosine of B equals 7 over, and then the hypotenuse is 8.6. Okay? And the very final one, they give us this triangle here. Six, 8, and 10. And then they give us angle C here. Again, this is a right triangle. And they ask you for the tangent of angle C. So I'm going to come over here and just write tan C. And remember, going back up here, so ka toa, we're going to deal with toa here. So tangent is equal to opposite over adjacent. So looking at angle C, we're going to do the opposite, which is 6, over the adjacent side, which is 8. And again, you could write any of these fractions if you want as a decimal. I usually just leave them, but I think in your book they kind of round these. I think they gave this one, they said this is like 0.57. 4 divided by 7 is approximately 0.57. 7 over 8.6 is approximately 0.81. And then this one is nice and easy. This is 0.75. Okay? And so those are the three right there. So sine A, cosine B, and tan C. Okay, so for the next part, that's example 1. Now, they actually want you to find the inverse of these, okay? So, this is example 2. It says, the inverse sine of a number is the angle whose sine is that number. Okay, so they talk about that. I'm going to actually do this just to show you that idea, okay? So if I wanted to figure out, well, what is angle A? I would need, in order to undo basically the sine, because this A is technically inside of the sine, it's saying sine of A. So in order to undo that, I have to take the inverse sine and use this ratio or decimal. So if I want to know the angle A, want to know what angle A equals, I can actually undo the sine by saying inverse sine. And that's what that looks like, sine with the -1. That's the inverse sine. And then what I'm going to do is plug in that 0.57. And then I'll be able to see what angle that is. Okay? So if I look on here, I can actually press second sine, and then that again brings up the sine with the inverse. And then I'm going to put 0.57. Or I could use 4 over 7. Okay? It's going to come up to be about 35 degrees, and I think what they want you to do is, I think we want to round these to 2 decimal places. So this, angle A, would be approximately 34.75 degrees. That would be the angle A. Okay? Let's go to example 2 and see what they want. So they say on here for A, example 2A, they say the sine of 30 degrees is 0.5. Okay, so they're saying basically you've got this sine of this angle, and I'll just show it as a I'll just say it's an angle. Okay, sine of an angle. They're saying it is 0.5, and then they're saying that this angle is 30 degrees. Okay, so we're just going to check on the calculator and see if that's true. Is A 30 degrees? Okay, so what we can do, clear this out. Again, press second sine, and then we're going to put in 0.5, and look, it's 30 degrees. Okay, so that's true. So they say, okay, so sine of 30 degrees is 0.5. Okay, that's what they're saying. But notice that, in order to solve for A, all I had to do was take the inverse sine of this, okay? So I'll show you another one. So B. They say the cosine of 30 degrees is approximately 0.866. So that means that the inverse cosine of 0.866 is 30 degrees, okay? So I'll write that. So cosine, let's say, of A is 0.866. And so if I wanted to find angle A, and I'll write what I would have written on this one, I would do the inverse cosine of the ratio that, or the decimal that I was given. Okay? And again, I should get 30 degrees. So let's try that. So clear it out again. Now I'm going to do second cosine, and that's going to do the inverse cosine. So make sure if you're finding an angle, you're working with the inverse. And then I'm going to put 0.866. And there it is, 30 degrees. Okay? So again, this whole lesson really is about you either writing the ratios of sine, cosine, and tangent using the side lengths, or you can actually solve for the angles, okay, if you're given a ratio or a decimal, okay, by using the inverse. And then I think on the very last, even though they don't have it as an example, I'll just give you this anyway. On here, they just say use a calculator to evaluate. So I'm just going to do an example. And I'm just going to put in, let's just say they give you this. So let's just say they give you 5 cosine 75 and they say evaluate it. So just go in here, okay? I'm going to press clear, and then I'm going to put it in just like it appears, 5, and then I press cosine 75. And since I'm in degree mode, it's good. And I end up getting 1.294. Okay, so that's approximately 1.29 if we're going to round to 2 decimal places. Okay, so in your book, you're going to go ahead and do the examples in class, and then you'll be able to finish your homework from there.